All right, we will continue in the red room with the North Korean malware attacks. Please join me in welcoming Peter from ESET, who will talk about the Lazarus Group and their latest operations. Peter?
Yeah, thank you. Hello, welcome to our talk. My name is Peter. This research was done together with Michal. Poslušný, we are from ESET, Czech Republic. We have a lot of slides, so let's go straight to the point. Lazarus Group, a mahjong game played with different sets of tiles. What does it mean? What's the idea behind the title? Mahjong is a game, tile-based game, originated in China in the early 20th century for 3 or 4 players, and basically it later spread to the neighborhood countries in the East Asian region. And during our malware investigation, we have found a lot of traces that were associated with exactly this part of the world, like many victims, CNC servers, language and cultural references. So we had some kind of geographical reason. Next, there is a simplified computerized version of the game called Mahjong Solitaire. This is kind of new game, and it's a single-player matching game. And the rules are as follows. You have a board with a lot of tiles, and if you have 2 unblocked tiles with the same image on them, you can pair them and remove them from the board. So you unblock more tiles, and you continue in this manner until you clear the board. And at that point, you've just solved the puzzle. What's the analogy here? Actually, we imagine of the tiles as relevant static properties from Lazarus binaries, mostly reported in big cases, and for example, CNC servers and chunks of codes, character strings. And the goal was to find a match with the tiles extracted from new, unrelated incoming binaries. So we could enlarge the pile that we briefly mentioned as Lazarus toolset. So that's the idea. And why the word different in the title? Because this is related to the peer-reach headers analysis, and we mentioned it in the second section. So let's briefly mention the outline. We start with the reported cases. These are not known, so we try to spend as little time as possible with this section. Then we will mention main characteristics that helped us to play the game, the matching game. And finally, we will conclude with 6 case studies of Lazarus attacks that we believe are not well known. So let's move to the first part. Lazarus Group is the most tracked APT actor nowadays. And if you wonder what those Korean symbols under the title means, it's Kim Hyung-bo. And it is a virtual alter ego of a real person, a programmer from North Korea living in China, who was recently indicted by the FBI in this criminal complaint. And actually, it has 179 pages. Did anybody go through the text? Please raise your hand. Okay. The report is extensive, it's precise, it's reasonable. And the FBI investigation details very well complements traces that we see as malware researchers. So I really recommend to read this document. Basically, the FBI investigators also played Mahjong Solitaire, but the tiles were email addresses and boards were address books related to these email addresses. Those email addresses were from Hotmail and Gmail accounts. So they got visibility in those. By the way, there's a book online, Kim Jong-il's Leadership of North Korea. And on page 101, there's a fact that the second supreme leader of North Korea fancied mahjong in his free time. So, briefly mention the most important reports. Operation Blockbuster, February 2016, epic. Hundreds of pages. This was a source for future reference, for future work. And there was a description, not just the binaries from Sony Picture Entertainment hack, but also many other similar malware, starting from rats through spreaders up to DDoS bots. And ESET detects Lazarus toolset binaries as architecture plus NuxPet, And I guess Microsoft invented this name, and very likely it was created like Sony Picture Entertainment Data Nuked. Next important attack, Swift attacks, already mentioned by my predecessor. The attackers wanted to use not corrupted but fraudulent Swift payment messages against five banks. And actually, they wanted to defraud $1 billion in transactions, but they were successful only in 8% of cases, which is still quite a good heist. And this heist was later laundered through multiple bank accounts and money-remitting businesses and casino junkets. And this fact is from the FBI report. And you can see on the slide like the main traces that were a source for attribution. Another big important attack, firstly reported by Zaufana Trzecia Strona. It states that watering hole campaigns against Polish banks were one of the most serious cyber attacks in the history of Poland regarding critical infrastructure and banking sector. And I guess everybody knows details about this. What was interesting that, the attackers were successful against banks in Bangladesh and Vietnam and Mexico, and it was kind of surprising that they're also successful to get onto infrastructure of a member of European Union. Okay, I don't need to introduce the display screen. WannaCry outbreak, 12th of May 2017. What's interesting that P timestamp is obviously modified. It says November 2010. Okay, so that does not fit the intuition. And everybody, I guess, know how the threat was distributed through an exploit. The initial attribution was done by a Google engineer with a cryptic tweet. He mentioned two hashes and offsets of the P files. And you can see IDAPRO output the disassembly of the code at these offsets. Kaspersky Labs later added a hexadecimal string from the data section that was like shared passive table for TLS communication. So quite a strong links. I guess, okay, that we conclude the first part and we move to the second one. Sources of Lazarus hacking tools seem to be modified with every attack. As we mentioned already, Lazarus toolset is huge. There's no such thing as a general scheme that could cover all binaries from the toolset. But let's take a look at this dropper. It's from watering hole campaigns against Polish banks. The invisible number one, that feature is that the threat executes in a cascade. We'll explain in a while. Number two is that it is a console application accepting several parameters. Number three is that the binary resolves Windows API functions dynamically, one library after another. And finally, number four, that it uses RC4 like cipher to extract additional stages from the resources or from the overlay or from the data sections. Let's explain the number one, execution in a cascade. This slide shows various moods of Matryoshka doll. It's a Russian toy. Basically, you have one layer, you uncover it, you have another layer, you uncover it too, and you continue in this manner. So let's take a look at the first layer, a dropper. Looks pretty benign, innocent, and it is actually, because there's no obfuscation, no signs of polymorphism, no anti-analysis. It just extracts additional layer. The next stage, a loader, that displays some kind of maliciousness because it could load as a Windows service with persistence. It could load additional stages from the registry or from Windows system files. And finally, a module, the payload. It could be anything from a DDoS bot to a rat. Let's take a look at dynamic resolutions of Windows APIs. We extracted 8 Windows APIs that were kind of similar to many of Lazarus binaries, like Windows exec connect, get logical drives, get adapters info. And we tried to find variations of these and which kind of like encoding or encryption the guys used to obfuscate these function names. And what do the colors mean here? The red cells represent function names used in the big famous cases. And the blue ones are from the cases that were not reported, but we attributed them to Lazarus. And the yellow one is from Operation Troy. It dates back to 2009 or 10, but the binaries from this operation displayed a lot of anomalies that we kind of were confused, and so we excluded binaries from Operation Troy within our consideration. This is an analogic table for format strings. The writers of Lazarus tools love to format strings, especially a command that would run a console application and collects its output. And we have found 20 or 30 groups or methods how they obfuscated this formatting string. And you can find more in the paper, because this is just an extract. There are many more methods how they did it. These are just the main known cases. Let's say a few words about fake TLS protocol. On the screen you can see how malware prepares a buffer on the stack that would represent like connection, malicious connection. It looks like TLS protocol, but it isn't. And it uses some popular domain to mimic the connection. So perhaps some intrusion prevention systems would not recognize this as a malicious connection. And we have found various different sets of popular domains that were like misused in this sense. For example, regarding the popularity, Baidu.com is #1 in China, Naver.com is #3 in South Korea, VK.com is #1 in Russia. So the conclusion is that the attackers haven't excluded victims who would be who could use this kind of services. Another very interesting feature, self-deleting batches. The purpose of these batches were to delete stages of malware that were not useful in the stages of attack. And these batches played a key role in many attribution cases. Again, I refer to the paper. We have found far more examples than they are displayed in this slide. And let's say a few words about our p-rich headers research, or mostly linker versions of binaries that were attributed to Lazarus. We took 32-bit files from the toolset, and we're curious about which Visual Studio produced linked these binaries. And we found out that 95% of 32-bit binaries were linked with Visual Studio 98 and 2010. And the rest were some anomalies like 2012 and VS 2013. What's interesting that if we did it for the 64-bit landscape, we arrived at 95% of binaries linked with VS 2010, which is a good agreement. And again, some anomalies like 2012 and VS 2013. So, however, we have found many different anomalies. So if we could just very roughly classify cells like operating by cells of Lazarus operating, it could be one cell that uses Visual Studio 98, then a cell using Visual Studio 2010, and then a few cells that we don't know which entities they are. And we found more these kind of anomalies. As I mentioned already, Operation Troy and binaries from it really didn't fit the whole scheme. However, manuscript mentioned by my predecessor, a.k.a. Felchill, was also produced by VS 2012, which does not fit the scheme. And also the recent Bitcoin-oriented attacks and binaries used in them using VS 2015 also do not fit the scheme. What was even more disappointing that we have found what I would call mixed cascades. So imagine you have a dropper linked with VS 98 that drops like two loaders that were linked with 2013, and they loads a final payload that were again compiled with Visual Studio 98. and what I would call unusual architectures. So, as I told before, there was an agreement between like Visual Studio 98 and 2010. However, we have found exactly the same project compiled as or linked as Visual Studio 98 in 32-bit like landscape, and not 2010 but 2013. So another like anomaly that we couldn't explain. And let's move to the final part, our six case studies. I guess you recognize this theme, variations of Marilyn Monroe by Andy Warhol, a pop art piece. This is like, instead of Marilyn, you can see like Splash from WannaCry 2.0. But if you go like a few weeks earlier than the outbreak time, you would arrive at what people call version 1 of WannaCry. It was like P timestamp set March 2017. It was not spread by the exploit, of course. It was spread by the stolen credentials of SMB logins. So the impact was pretty low. The design is roughly the same, except the title, which says the version number. If you move 1 month earlier, you would arrive at this piece, so-called version 0 or beta version. P timestamp says February 2017. Design slightly changed, not red but green colors. But statically, the file was also like similar to version 1 and distributed in the same way. But I'm not sure if you know this one. I would call it version -1. We haven't seen any reports about this one. And the P timestamp says like August 2016. And of course, P timestamp could be modified. However, the first submission date to the virus total service says September 2016. The design is roughly the same as the version 0. So the conclusion is that the concept for WannaCry existed already in 2016 on virus total. Let's move to the second case. This is a glitched version of a banner that we used in our watering hole report on the attacks against Polish banks. Why we did choose such picture? Because we found this attack at the same time. It's February 2017, and several Java downloaders like hosted on this remote storage. And you can see the Java code. It's basically just it prepares the payload. And on the right of the Java code, you can see a switch. It checks the victim's environment. If it's Windows, then it will do what one expects. But if it's not, then it would download a binary called something like linux.bin. And we weren't able to acquire this binary. And actually, it's very like, it's suspicious that the code does not check the architecture in this case, because in Linux environment, the architecture of ELF binary needs to fit the environment of operating system. So we believe that this is just a testing code, and there was no real mechanism behind this. How we did the attribution? So for the Windows binaries, we were able to acquire those, and we found a dropper there. We extracted the modules. One of the modules were a keylogger, but one of the binaries was a backdoor. Very likely, very, very similar to one that was reported in Operation Blockbuster. So we concluded that the whole attack is attributed to Lazarus. Case number 3, I guess. What do you see on the picture? A grave, a tree growing out of the grave, having big black poisonous fruits, a guardian hiding behind the grave, and a snake in front. What does this mean? In September 2017, the core image of the previous you see, we reported about this Monero miner. Like it was spread through remote code execution against 32-bit Windows servers 2003, an ancient systems dead since July 2015. And the proof of concept was published in May 2017. And we were able to capture the whole chain. So we concluded that there could be a single actor behind this attack because the final payload was just modified open source project for monorail mining, and the exploit was just a copy of the proof of concept. So no complicated like approach. So it was just collecting low-hanging fruits from the internet. What does do this with Lazarus? We found another payload, and we detect it as nukespet.bu. As we mentioned earlier, we detect Lazarus stuff as nukespet. And these were the remote storages that distributed the payload. However, we didn't capture the exploit itself, so it was really like low prevalent. However, the metadata regarding the attack were very, very like persuading, convincing that it was remote code execution against those ancient systems. The attribution was done through two traces. The first one, shared network infrastructure from a different Lazarus file, and these two debug strings that were found only in binaries related to Lazarus. What was interesting about this, that the dropper was not benign that much. Actually, there was a compression layer over the dropper. It was a open source project called DXPEG. There's a series of blog posts from 2014 that gives you instructions how to create your own malware packer. So I guess the attackers just followed these hints. And there's not much obfuscation, not much anti-analysis, not much polymorphism. It's just UPX-like compression without a static unpacker available. Let's move to the case number 4. What do you see? I can see Lazarus with his eyes covered with a vial and the hidden cobra behind him and the Chinese letters. What do those Chinese letters mean? If we want to understand this scenario, we need to switch to Chinese. We found a very rare, very strange binary, which was a server part of a remote access tool. And this binary was expecting an INI configuration file with the section name Fubuki, which is a pinyin romanization of those Chinese letters, and it means server. And the attribution to the WannaCry or to Lazarus was done through the list of big corporations embedded in the binary. And actually, there were more traces, like we also found client part that was distributed in the pre-outbreak period. And what was really like strange, there was a list of South Korean TV series embedded in the binary. You can see them on the right. We constructed some of those series, like, I don't know these like pieces. Case number 5. What do you see? I see anxiety, maybe depression, death. I see a lot of sad faces, like around the central aggressive theme. And perhaps this is the same feeling that the people from online casino in Central America had when their infrastructure got kill-disked. And the distribution method was known. It was weak logins through these remote access tools. Like the attackers dropped a lot of files on the infrastructure of the casino, TCP backdoors, session hijackers, virus loaders, and kill disks, of course. What was strange, that the binaries were obfuscated with VM Protect, recent versions, and Tamida. And when we blogged about this, many people who I know that try to track Lazarus were not really convinced that it's Lazarus, so I had to explain them more carefully. And basically, it was done through two main like traces. The first one, if you like unprotect those Tamida files, you would find these like TCP backdoors and format strings that they use. But more strongly, there was a session hijacker reported by Kaspersky related to watering hole attacks against Polish and Mexican banks, and it was Temida-protected variant of the exactly same tool they reported. So we concluded that these two links are strong enough to attribute the attack to Lazarus. Perhaps the attackers were a little bit cynical because they chose lovebet.publicvm.com as a CNC server. And this is another trace that the attackers built their tools in front of, before every attack. And these are some of those indicators of compromise. And the attackers mimic file names with those three-letter shortcuts, DRV, SVC, CRV, which could mimic Windows files. Moreover, however, two interesting files, diamonds.exe, which was reported by Trend Micro in connection with attacks against financial institutions, and mso.exe, which was reported, the same file name could be found in the report by Kaspersky in their Lazarus Under the Hood report. Those were Swift attacks. And the final case. Unlike the previous cases, we have only weak to medium confidence about this one. Let's explain why. It's a strange coin miner. The distribution in the first phase of the attack, it was really rare vulnerability through managed engine service desk tools. We couldn't confirm that it's exactly this distribution, but our customer reported that it was the way how they got in. But we checked the Montreal wallet, and it was almost empty. However, in the second phase, the Montreal wallet increases 10 times, but we didn't know a distribution method in the second phase, but small and medium-sized businesses were affected. And this is the attribution. We based it on rich header metadata, basically these two projects, one this Bitcoin mining service and one installer from the multi-platform Java downloaders case, were roughly of the same size and linked with the exactly same version of Visual Studio. Both used RC4 encryption. However, the Bitcoin mining service, we will see in a while, used a little bit different RC4. It was not exactly the one that we know. And both of these loaders use SDP file names to store encrypted content on the file system. Not exactly the same, but however, the file path was the same, and the service name differed. And this is the RC4, normal one. There's a pseudo-random generation part and decryption itself, and the attackers added one command. They skipped every even iteration of the pseudo-random generation part. So normal decryption tools for RC4 didn't work. So let's summarize what we heard. Lazarus is the most tracked APT actor nowadays, which is good because if you shine on the cybercrime scene, you decreases the possibility that you slip through defenses. Source codes of hacking tools seem to be modified with every attack. LoveBet, CNC. We have found several cases, binaries from VirusTotal that contained username embedded in the binary, username of the victim. And there are quite a lot of instances of Lazarus that have not been completely resolved, completely reported, completely attributed. So really, huge tool set, and not everything is clear. I guess that's all from me. And actually, this year, Virus Bulletin does not have football table. However, we are preparing a meeting tonight at Fitzroy's, and you can join our Slack group channel, and perhaps we will meet there. If you have any questions, I'll be glad to answer them. Picture credits for these artists. And that's all.
Thank you.